All right. It's been a minute since I did one of these. I'm actually kind of nervous. Yeah, that's the goal. By the way, can we get another round of applause for the people who donated the beer? Because I'm a big fan of anyone who makes a donation that results in me getting beer. So let's keep doing that. So I'm supposed to be talking about test queue tonight. Truth be told, this is probably going to be a little bit of a boring talk. It's nothing exciting, nothing new, nothing flashy, but it is something that's going to make your life a lot better if you use something like test queue to go ahead and start running your tests. So what is test queue? Well, the point of test queue is it makes your tests run fast, right? And really this is kind of taking advantage of the principle that if you go ahead and grab something like test queue, and then you go ahead and distribute the load of all your tests a bunch across the CPUs, right? It's going to run a lot faster because you can parallelize a lot of these workloads fairly effectively. Test queue does it in a couple of interesting ways that are a little bit different from things like parallel tests that have been out there for a while. But the point being is that test queue will let you use the cores that you have available, whether it's locally on your existing machine. One of the really cool things about test queue that we'll talk about later is that test queue lets you use just any TCP socket as a relay mechanism between workers. What this means is that you can effectively offload running tests to a bunch of machines that are remote, not just running on a single machine with a lot of cores. And the nice advantage of that is that it's pretty easy to spin up instances very rapidly and run your test suite spread across a number of them, right? This is in fact something that we did at GitHub, albeit not with necessarily cloud machines, but we had a bunch of slack capacity on Metal, and we parallelized the test suite there across 128 cores simultaneously, getting our test times underneath 1 minute, right? And that's some pretty quick in terms of feedback loop. Which cloud? I don't care. Some of you know I work for DigitalOcean. Like, use whatever, man. Like, DigitalOcean will work, but AWS is fantastic. Azure is fantastic. Gets a lot of crap because it's, you know, from Microsoft, but Azure is actually really good. And of course, you've got Google Compute Engine and all that stuff too. So really, let's get diving into how test queue works internally, which is it takes a socket. In the case of local work, it's a Unix socket, and in the case of remote work, it's just an ordinary TCP socket. You go ahead and you spin up your master process, you load your Rails app and everything, and then you fork a bunch of worker processes from that, right? And then what you do is you smartly distribute tests. One of the really unique things about test queue that makes it a bit different from things like parallel tests is it actually learns how to better distribute tests the more often it runs. And the way it does that is actually marshals down into a binary file, basically a mapping of test suites, specifically test names or spec names, to the amount of time it takes to run it on average, right? And what that allows you to do is over time it becomes a bucket filling problem so that all of your workers tend to finish about the same time. And the end result of that is your test suite is the fastest it can possibly be distributed across that number of cores. The goal here, right, is that we want to spend less time waiting on our continuous integration. The reason being is that we want to spend more time shipping code. I think that's something that we can kind of all agree is a safe assumption here, is that the less time we spend waiting and the more time we spend doing, the better. So let's talk about getting started. This is going to be sort of a very hands-on demonstration with a couple real code bases showing you how this gets integrated into a real project, because a lot of it is non-obvious and the documentation isn't necessarily the greatest. So installing, right? It's pretty simple. It's just gem test queue. You put it in your gem file, you move on. This is perhaps a bit smaller than I would like, so I'll go ahead and just kind of hand wave at it and describe roughly what's going on, because we'll show you with the real editor and real code later. Basically, all you do is you pull in your test helper and you pull in test queue, and you declare a custom runner, and then you execute the test with it, right? And you put this all in a script in your Rails app or your Ruby app or whatever. It's called script test queue. That's just a convention that we use to GitHub. You don't have to do it as long as it's a sort of script that you can execute. So there are a few components here that are really necessary in the case of, in particular, Rails apps. One of them is after fork. Much like Unicorn, anything else really that forks, you can't necessarily rely on any connections the master may have made when it spun up the process. So you need to do things like reset your active record connections, reconnect your Redis client to use a separate DB for the test so you have a clean environment to work in, that sort of thing. One of the things that's interesting here you'll notice is we're actually shifting on to our test database number. That's because naturally, if you're running this even on a local machine, you want to go ahead and make sure that you're using a clean database for each test runner that's been forked off, right? Otherwise, you can end up with really weird race conditions, and you don't want that. So another thing that you can do is you can define a prepare method in your custom test runner. What this allows you to do in the particular case here is I use it to grab the database schema and then load a clean copy into a test database. The advantage of doing it this way rather than doing it with something like environment variables and running rake db create db migrate is that you don't have to boot the Rails app each time you do it, right? It's very fast. If you just shell out to MySQL here, for example, or pSQL will be at the case. So here we get to the actual fun stuff and the code you can read because the text will be big enough. So let's go ahead. And I made a sample application. As we all know, all Rails apps start as some form of a blog, preferably done in 6 minutes. So I wrote a 6-minute web blog, as we all do from time to time. So what I'm going to go ahead and do here is open up first my script test queue. And hey, that might even be readable. So as you can see here, this is going to be using RSpec because I'm biased and I believe in using the only correct test framework for Ruby. So we shove the spec directory onto the path, and we use environment test queue workers to control the number of workers we're running. We require a Rails helper because that's a convention now apparently, and we pull in test queue and test queue runner RSpec. So from there we get into the meat of like doing some real stuff. So you saw the example before with active record shoving, in this case, the number of the database onto it and establishing a connection to the test database again. Here you can see some like real-world commands that are actually usable for getting your database dump and then loading it into a test database for each one of these things, right? And like I said, this is just way faster than running bundle exec rake db create a bunch of times because that's going to boot like a lot of your Rails app to do it. That's really slow. I don't like slow things. And the way this actually ends up working is pretty quick. So before I get into running that, this is, like I said, a 6-minute web blog. I spent probably 6 minutes building it, so I didn't have time to actually acquire all the cruft that happens in like a long-lived Rails code base, tests going to the database constantly and stuff like that. So I had to cheat. I had to like simulate what's actually going to happen with a slow test framework, which sounds weird, but it's just a factor of time. So as you can see, we have some slow tests. This is your Rails app on databases. This is basically you just sleep a lot during your tests, or you might as well be. So what we're going to do is, and we have a bunch of these. What I'm going to do is I'm just going to run script test, which is just a bash script that I'll show you here in a second. You can see here we had one worker finish really quickly because that's the one that's not running slowly. The others, we have a summary broken down by workers. If we had failures, we'd get a summary of those as well above the individual cases here. And you can see that took, if we run it again with time, it'll be real quick. It'll be like 4 seconds, right? It's not going to be very slow. And we can see that's pretty tolerable, right? But if we go ahead and just run these serially, what we'll find is that it's actually really slow to wait for because we're doing that just in serial, and that's the nature of the problem, which seems fine when all of your tests are doing sleep, right? When they're not doing anything useful. But like I said, we use this exact same gem, this exact same technique when I was at GitHub to get the test time of our main app, GitHub down to 30 seconds, right? So this is a real Rails code base. This is actually a Rails engine. It's not a Rails app in this case. But this is something we use at work. And I have a branch where I've been rolling this out there because people were tired of waiting on CI. And I believe in helping people out. So if we go ahead and run script test here, this will take probably on the order of like 30 seconds. Now the cool thing is that on my laptop right now, this takes about 2 minutes because I've got fairly fast cores. So that's about a 75% speed up. That's pretty legit. But on our actual CI machine, because it's running in a droplet, and of course the nature of sharing CPUs is that you get less CPU time, and therefore things run more slowly. And CI there now takes on the order of, because it actually does it once under Rails 3 and once under Rails 4, I think, takes like 4 or 5 minutes. So you can see that finished pretty quickly. You'll also notice these are all fairly evenly distributed, like I talked about, 19.9 seconds and 20 seconds, rather than ending up with like a particular slow test case dominating one of your workers and causing the whole test suite to take much longer. So the pattern here really behind this, like I said, is a little bit of shell and Ruby to go ahead and make the thing tick. And this is kind of really what I want to show off, because this is kind of driven by some of the patterns that we did at GitHub. And I think these patterns apply to a lot of Ruby and Rails applications, and even ones that aren't Ruby and Rails. And I would like to kind of see people embrace them a little bit more. So I figured I'd walk through these a little bit, just because I like shell. Not everyone likes shell. There are a lot of shell haters out there, but I like shell. I love shell. Shell is pretty much the greatest, right? And I mean the language, not like the CLI is good too, but like the language is pretty fantastic in its jank. So we're always invoking the script bootstrap. I'll show you. There's some cool tricks here. If you want to make your bundle times really fast, as it turns out, avoiding doing work is always the fastest option. So there's a few cool things I can show you that we do there. One of the things I like about this script in particular is that it doesn't get in the way of your typical development workflow. In particular, the notion that if there are arguments, we go ahead and just call rspec directly. So you can still run focused tests and isolated specs and stuff like that. Otherwise, we go ahead and just grab the number of cores that you have and set a few settings and just invoke the test queue Ruby script we wrote already. And if we go ahead and look at Bootstrap, this is where we get into a little bit more of the fun stuff. Specifically, we have this cool thing that checks basically the contents of your gem file, the arguments given to bundle when we actually run it, as well as the contents of script bootstrap. If those things remain the same between runs of script bootstrap, what we'll end up doing is it will never actually call bundle install, which even if you don't have any changes to effect, takes several seconds in large Rails apps. Again, sort of the nature of the problem. And all we do really is we store a checksum of that stuff in the temp directory as bundle.sha, and therefore we avoid doing that. Now where it starts to get even better, as anyone knows with a large and historied Rails app, is that pulling in the database schema and running migrations takes a lot longer, specifically because your Rails boot time tends to be, again, pretty long. And it's the same sort of concept there, is we basically go ahead and get the SHA of all of the content in the migrations directory and track that in the temp directory locally. And if it ever changes, we'll go ahead and recreate the database when you run script bootstrap. Otherwise, it'll go ahead and skip running that. Now, the big benefit there, as you saw, is that in the case of our example application, we really don't spend a lot of time outside of just booting the app the one time and actually running the tests. This is the test suite where, in theory, everything should take about 3 seconds to finish, and we're talking on the order of 4 to 5 seconds, which means that we're talking about a 1 to 2 second overhead for actually just booting the app and doing the miscellaneous stuff around bundling. If we actually broke this down into its individual steps, what you'll find is this tends to approach on the order of like 10 seconds, just for like a really dumb app like this. Bundler is actually incredibly inefficient, so anytime you can avoid calling bundle install is usually a good time, good time for you. Moving on.
Could you guys incorporate that themselves directly into Bundler? Could Bundler just incorporate that strategy?
Which bit, like the not actually doing work? There's still some work they have to do there with regards to resolving the dependency graph. One of the things you can do, and this is another pattern that we actually employed, is there's a flag for bundler called standalone. And the really nice thing about that is what it generates is inside the vendor directory, is it'll put not only all of your gems underneath a certain path there, but it'll put a file called, it'll be vendor bundler setup.rb. And what it'll do in there is it'll actually just be a static set of load path directives to go ahead and shift all of your gem paths onto the load path. And if you run bundler in standalone mode, then all you do is require a relative on that vendor bundler setup.rb, and you will skip all of the overhead that typically comes with bundler. Unfortunately, there are some other side effects of using bundler in standalone mode, and not a lot of people are used to working that way. So I tend to focus sort of on what the typical pattern is. But to your query, yeah, using bundler in standalone mode will allow you to avoid that sort of overhead when you're booting your app or running your rake tests and stuff like that. Cool. So advanced usage of test queue, again at a very high level. I talked about remote workers. They're actually pretty easy to use. As with any well-written piece of software, they use environment variables for configuration. And the end result of that is that by setting just a few environment variables in the right places, you can actually have a distributed system for running all of your tests spread across all the cores you could possibly want. In this case, we use a relay token, which is our shared secret. It's how nodes know that they're actually allowed to talk to one another, right? We set verbose because seeing all of the things when you're running tests is usually pretty good, especially in CI. This particular invocation here, test queue socket, just specifies the socket that test queue should spin up a worker on. The interesting thing about this flag is it means that that worker will never actually process any tests. All it does is act as a mechanism for relaying information to and from workers. And setting test queue relay here basically specifies this is going to be a worker mode that should talk to a master, relay its results when it's done running its particular subset of tests. And these are all sort of the primitives. Unfortunately, there's not like a package that ties it all together. But this is exactly the same way we ship this highly distributed method of running the test suite at GitHub. And like I said, the primitives are there. It's really not hard to stitch together. There's a Jenkins plugin that allows you to use what's called parameterized builds. So basically, you can trigger multiple builds at the same time with different parameters, those translating to environment variables at a certain point. And that allows you to effectively say, start 8 jobs at the same time in Jenkins and have 1 job run as the master, 7 run as workers, and they end up dividing the test suite up and running the whole thing. You get the result all reported back to one location, and everything's nice and neat. So like I said, you should combine it with your CI system to run your tests faster. That's a short talk. Thank you very much for listening. My name is Will Farrington. I am Dubfar on the internet. I kind of feel woefully unprepared. I threw this together because we didn't have a speaker lineup this month, so hopefully it was entertaining. Wow. But you can find the sample code with my simulated Rails app on database at dubfar/6minuteblog on GitHub, and you can find testqueue at tmm1/testqueue. Thank you very much. Are there any questions?
Is your bin bootstrap out there too?
Script bootstrap? No, but I will make a repo tonight. I will do it for you. Yeah, no, these are totally reusable patterns, and that's the nice thing. Like, the really cool thing about that is we did this in every repo at GitHub, right? Like every repo had script bootstrap, everything had script CI build, everything had script test, and when you only work on like 1 or 2 repos, that may not be a big deal. But like inside GitHub, we had like 750 private repos when I left, which is a lot of fucking repos. And even if you don't touch all of them every day, being able to at any point to jump into one and just run script bootstrap, for example, was like a godsend. It just worked the same way, whether it was a Ruby app or a Go app or a C app. It just worked. Yeah.
Will, does this run on Linux too?
Yeah, absolutely. In fact, that's at GitHub we use Jenkins on top of Ubuntu, and all the stuff ran there. But these are just straight Unix primitives. So as long as you can create a TCP socket and or a Unix socket, you're fine. So. Yeah.
So I know on a project I used to work on, I think we used parallel test or whatever the other one you mentioned was, and we had like a crazy thing where we generate a bunch of databases with separate numbers because we weren't running everything in a transaction. Is that what you would still recommend with using with test?
That's exactly what we did. Yeah. So if we look at this real quick,
it just felt really janky, so I didn't know.
So it is janky, but you need the isolation, right? And that's really the only reason for it. So. Specifically, the way it ends up working here is in this prepare. We go ahead and grab a dump of the test database schema as it is, and then for each of the test databases we need to create to run in parallel, we drop the existing one, create a new one, and then dump the schema into there, right? And then all we end up doing is we have this after fork, which contains the worker number, which is the unique worker ID here. We just shove the number onto the end of the test database, and that's how that works. A necessary evil, but as it turns out, doing it this way is still very, very fast. And this particular chunk of code here, this prepare, was actually running every time. So obviously a lot faster than running bundle exec, rake, db create with environment variables. So cool. Any other questions? Steven?
So that does require schema.sql, not schema.
Nope.
RB.
No, this dumps it from the live database. Okay, though, as a part-time DBA at work, I do have to say that structure.sql is in every way superior. It makes your life a lot better, and like there's nothing like it in terms of just like straight up usability. I don't know. Schema.rb has some things that make me angsty, and structure.sql is exactly what you would expect every single time. That said, we ran into a fun issue the other day when I was actually rolling this branch out. I should mention, never use like native foreign keys in a database, which again is a DBA faux pas because they're like ivory tower, use everything in the database because I'm the only one who can do it. But seriously, it makes your life horrible in one particular way if you're a Rails developer, which is that structure.sql and schema.rb don't actually pay attention to foreign key constraints and ordering. If you actually look at like a schema.rb or structure.sql, all of the tables are in alphabetical order because it's a nice reproducible configuration and it keeps your diffs nice and clean. Now, where that doesn't work is if you have a table that comes first that has a foreign key constraint on a table that comes later, because it reads the thing top down and creates the databases in order, which is actually another problem that concerns me with Rails adding native support for foreign keys going forward. But your mileage may vary on that one.
That sounds very fixable, though, in the dumper.
Yes and no. I mean, effectively, what they're going to have to do is like dependency resolution on the database tables, right?
Either that or save the triggers till the end of the schema file.
So that's the other thing you can do is at load time, you can specifically disable foreign key constraints from checking while you're loading in the schema. But something I would be a little bit wary of, especially if you're then going to like dump Cs into it, right?
Have you guys used any using any Postgres' tricks for like just copy this schema or give me a snapshot and just recreate that 10 times because you've got 10 cores or whatever?
Yeah.
To avoid all this schema, drop database, create database, load schema.
So yeah, I mean, you can certainly do that. Under the hood, it's doing all the same stuff, right? You can certainly set it up such that in a database like the case of Postgres, you can have a template for a database, and you can say create a database like this template, and stuff will work. We use MySQL at DigitalOcean and at GitHub mostly because we've got really big databases, and a lot of the tooling with regards to operating MySQL at scale is just a little bit more battle tested, and there are frankly just a lot more experts out there, right? Like it's one of those interesting things. I don't want to drag on too long about that particular thing, but you can certainly do it with Postgres. It's a feature in Postgres that you can do, but you don't have that in MySQL. There's no equivalent to create database like there is with tables, for example. So
easy one. What do failing tests look like? Is it like actually a nice readable output?
Cool. Yeah, I think it's pretty readable when tests fail. So let me go ahead and just make one of these fail, which shouldn't be that hard, because I mean, this is great. So we're gonna this is Pro Ruby right here. This is actually the topic of my first book, How to Write Tests Like a Pro. And yes, this is in the fake app. Yeah, it's the high quality testing. So we're going to let this run. So you can see here, just in the summary, we have all the workers, and then we just have the regular summary of failures like you get from RSpec or Minitest or whatever. So they all aggregate at the bottom, which is pretty nice. Makes it easy to read.
Can you get it to or shut down all the other workers if there's one test that fails, or fail fast.
So
yeah,
as far as I understand, fail fast hasn't been implemented in the master worker setup here. You in theory could, but I think by default, if you pass the argument right now, each worker would just terminate once it encountered a failing test. Now that said, if you're the whole goal, right, is that your test times are really fast. So I guess it's not so bad waiting on multiple failures, right? So I don't know. It's certainly something that could be done. I'm sure Aman would be happy to accept pull requests.
So you talked about distributing the load of tests equitably so you get a nice even test run as fast as possible.
Yep.
What about test ordering in that situation? So now you're filling the same bucket continually with the same set of tests. I suppose you can run random order within a bucket.
Yeah.
Right, but you're still, I guess you are limiting the randomness a bit.
You are a bit. Now, the cool thing is that all of this information is actually stored just in the local directory. There's a test queue stats file, which, like I said, is just a Marshall dump. So if you ever want to play Havoc and find all of your tests, you could certainly blow this away. You could definitely make this randomly ordered as well. All it ends up using internally is a very simple queue with just push and pop, and that's how each of the workers pull tests off of the master. So you could certainly randomize order or provide some sort of like weighting scheme to adjust for avoiding repetition in your bucket filling patterns. Cool. All right. Well, thanks everyone. I hope that was enjoyable, and if not.
This video has been sponsored by Rieta Incorporated. Learn more today at rietta.com.